Does anybody have their national board paper? So y'all can get on them. Okay, I can just go through the list so we can see who still needs to bring one. Brian, Matthew, Josh, Janeth, Sebastian, Serenity, Daniel, Alfonso, Jocelyn, Cody, Dylan. I don't have a student release for you. It's an easy 100. So please bring it back. Today, what we're going to start, like I said, it's our new unit and it's quadratics. Y'all have done quadratics before in Algebra 1. We're going to do it again in Algebra 2. It's important to know what we're doing. And so we are solving quadratics. We're going to solve them a variety of different ways. Like all we're doing for the rest of the year is quadratics. I mean, like the rest of the year till December. So obviously there's a lot of different ways that we're going to solve them, but you need to know what the solution is. The solution to a quadratic equation so the solution is simply where the graph crosses the x-axis. Okay, that's the solution. The solution is just where your graph crosses the x-axis. Angel, don't get distracted. We got math to do. Yeah. So the solution is where the graph crosses the x-axis. What do we call when you cross the x-axis? Right, an x-intercept. So we've got another word for an x-intercept is a root. So we actually have 3 different words that describe the same exact thing, and you're going to see them all 3 ways. We need to know that it's all the same. So when you see solution, when you see x-intercept, when you see root, those are all the same thing. It's all exactly the same. We are just looking for where your graph crosses the x-axis. That's it. So about quadratics, does anybody remember what that shape looks like? Yeah, it looks like another letter. It looks like the letter U. And there's only 3 situations that can happen. Okay, we've got this U-shaped graph. There's only 3 things that can happen. And so I am going to illustrate that for you. So I'm just sketching an X and a Y to show you the 3 things that can happen. So if you want to give yourself an X and a Y, we're just sketching what can happen. So just parent function quadratic. It starts at 0, 0, and it makes this U That's one situation. Another situation, that graph could be shifted down, and it doesn't mean that it has to be along the y-axis. Like it could be shifted down and over to the side. It doesn't really matter. So here's another situation. And here's another situation. And this all applies if you're flipped upside down. You could flip all of those same graphs upside down. Well, the answer is where you cross the x-axis. So we're going to look at this. The first situation, you actually just come down and touch and bounce off. The second situation, you go through twice. What about the last one? So remember, this is the x-axis. Jocelyn's right, none. It doesn't cross at all. It's none. It does not happen. So the number of solutions for the first one, there's one solution. For the second one, there are two solutions. And for last one, there's no solutions. And remember, we have this symbol for no solution. It's an empty set, no solution. So today, whole front side of this notes is where does your graph cross the x-axis? So let's do it. The directions, they say use the graph to find the solution set. Okay, well, the solution set is where your graph crosses the x-axis. For the first one, so for graph number one, you don't think it ever crosses? Yeah, I agree. That one crosses, yeah, at 4 and 6. So to write a solution set, you could say 4 and 6. For the second one, it looks like it just goes down and it touches and bounces off. -3, that's it. Okay, I'm really glad that you asked. Parentheses is not a set. We put parentheses around a point, and we put parentheses if we're describing like an interval, sometimes if it doesn't include the points, but parentheses it's not really the same thing. So I'm glad you asked. No ugly curly brackets. We got to just get good at drawing those. I would like you to, only because I want you to know that that's what it means. And sometimes you'll see questions and that is the answer. So I want you to know that that's what it means. Hello? I do. I sure will. McKenna, you are leaving. I know. What was the point, girl? What about the last one? None. So we would say the empty set. The next questions, use the graph to find the roots of the quadratic. Okay, remember that these words mean the same thing. Solution, roots, it's the same exact thing, same thing. So good news, Angel. For these, we're going to show writing it a different way. Okay, don't like curly brackets? Let's not put them. So for the first one, where does it cross the X? Never. So we can even practice writing it out. No solution. Just like they use different words to describe it, sometimes there's different ways to show the same answer. Yep. The second one. Looks like 0 and 4. So 0 and 4. So now I don't have anything. Now I have nothing. Just don't use parentheses. And the very last one. 2. Easy peasy, right? Easy. Like, who's gonna ace these questions on the next quiz? I hope everybody. I hope everybody. I hope everybody. All right, on to the back. On to the back, and my hope is that you have enough time to finish the homework today, but we got to get through this stuff. On to the back. The top says GCF. Who remembers even what greatest common factor? Anybody remember what that is? No, not really, but you can do it. So greatest common factor, we're looking for the biggest thing that we can basically divide out of both of them. So to show me your work, you're going to first look at the numbers or the coefficients. We have a 5 and we have a 45. Factors are things that multiply to give you a number. So like things that multiply to give you 5 are 1 and 5. And then you have factors that go into 45 too. What's the biggest number that goes into both 5 and 45? 5. So that is definitely the greatest that we can pull out for the coefficients. 5 and 5. Well, now let's look at the variable parts. So they both have an x. One is x squared and one is x. What's the biggest amount of x's that I can pull out? Just one. That's the most. So I have an x and an x. So greatest common factor is basically dividing out the biggest factor. So if I was to look at the first one, if I were to divide out 5, well, that becomes 1, right? Also, whatever you divide by has to come into the front. It doesn't disappear. It just goes into the front. So when I look at 5 and 5, that becomes 1. When I look at the x's, that one and one of those will reduce. So I'm just left with an x. I'm not doing anything with the plus sign. It's still going to be plus. What about 45 and 5? How many times does 5 go into 45? What? 9. 9 times. And then an x over an x, that becomes 1. I just factored out the greatest, I just did greatest common factor, factoring. The next one, I gave myself a little note. This isn't saying that you have to, I just want you to get practice. So I gave myself a little note that I wanted us to also factor out a negative because sometimes you have to do that and I want you to see what it looks like. But first we're going to look for the number parts. What's the biggest number that goes into both 14 and 28? Yeah, so if you did 7, what you would end up with is you'd have to do it again. So yes, 14 will go into both of them. Okay, what about the x part? Yeah, just I can only pull out one x. And I said that I wanted you to pull out a negative because my goal is that I want to make the number in between, I want to make this a positive because sometimes in the stuff that we're doing today, we need to change signs. So we're also going to pull out a negative. So I'm going to put a negative there. Again, whatever you divide by, your greatest common factor has to go out in front. So negative 14x is going out in front. When I look at my first term, it looks like everything kind of cancels, right? But I still have a negative. So it's just going to be a -1. Nothing ever fully cancels. It will always be a 1. In this case, a -1. For my second term, it looks like I'm dividing by a negative, so it will become a positive. 14 goes into 28 2 times. And for the x's, it looks like that'll change to a square. I'm taking off only 1.
It'd just be like, you're subtracting 3 from 1.
There is a way that you can always check your work because, hold on. Oh, I guess it only gives me that. Because to check your work, what you could always do is distribute. You would take and you would distribute this into both pieces and you could check your work. You should end up with what you started with. So this is just factoring out a GCF. The last one. What's the biggest number that can go into everything? 3. So we could divide by 3, divide by 3, divide by 3. What about x's? None. It's none because they would have to all have an x and only the first 2 terms have an x. So all we can pull out is a 3. And we pull it out into the front. You cannot pull out an x unless everything has an x. That's correct. Because it says greatest common factor. So common means everything has to have 1. So 3 divided by 3, that's just 1 x squared. 21 divided by 3, we get 7. And then 60 divided by 3, what? 60 divided by 3.
1.
That is it. Finding a greatest common factor. So there's a lot of times that I say, you've got to check for the greatest common factor. This is what I mean. So you got to pull out the greatest common factor first. Next thing that we're going to talk about is factoring a difference of 2 perfect squares. A difference of 2 perfect squares. What does difference mean? So difference means subtract. Do y'all know what a perfect square is? What? A perfect square is something just times itself. So a perfect square is 4, 16, it's 9, it's 25, it's 49. 25 works, 36, 81, 100. All of those things work. Shake your head if you know what I just did. I just kind of went through and I multiplied things by itself. So a perfect square, you can even just give yourself a short list so that you remember what is a perfect square. We've got 4, 9, 16, 25, 36, 49. Hopefully if you see that list, you'll remember, oh yeah, that's a perfect square.
That's just
1 works too. Yep, 1 works too. Good. Yep, add 1 to list. 1 works too. In fact, that's one that we most commonly overlook. I'm glad you said that. So there's 2 things that have to happen for it to be a difference of perfect squares. You have to be subtracting, and it has to have a perfect square in the problem. Yes, absolutely. 144 works. Yep. There's a lot. One thing that we have to do sometimes is check for a GCF. If there's not a GCF, then if we notice there are perfect squares, we're going to rewrite it in this format. You'll see why. And then once we have it in this format, then we have a formula, and it looks like this. So I'm going to kind of walk you through. When we look at question 10, we definitely are subtracting. And that is something squared because it's x squared. What about 4? Is that a perfect square? Yes. Okay. Well, I'm going to show you this step. We're going to first rewrite it as something squared minus something squared, and we're going to put parentheses around the something. So we have x squared minus, how would we say 4 is something squared? 2 squared. Good job. So it's 2 squared. So once you write it in this format, you have 2 somethings. You have this and you have this. When you have something squared minus something squared, we're going to set up 2 parentheses. It doesn't really matter which one, because I tell you that the formula, it could have minus and then plus, or it could have plus and then minus. It doesn't really matter. One of the parentheses needs to be plus. One of the parentheses needs to be minus. It doesn't matter where you put them. It doesn't matter. So you'll see me sometimes put them in opposite order, only because I want you to know it doesn't matter. And then the next thing that we're going to do is we're going to distribute out the stuff that's in parentheses, and these have to be in that order. So if the X is listed first, it has to go first. If the 2 is listed second, it has to go second in both of them. So I'm going to go put X and X, 2 and 2. Notice how there's no more something squared. You only rewrite the stuff that was in the parentheses. That's it. So that is factoring a difference of perfect squares. Question 11. We have a difference. Are those both perfect squares? Yeah, of course they are, because we just use the same values. And so we can rewrite it. That's 2 squared, and that's x squared. I'm going to have 2 sets of parentheses. Again, it doesn't matter which order that you put the plus and the minus, so I just switched it because it doesn't matter. Now I'm going to put the same values in, and they have to be in that position. So the 2 has to be first, and the x has to be second. So these are very similar, but they're not the same. If you multiply them out, these are not the same. It's kind of like saying 10 minus 6 and 6 minus 10. They're not, you don't get the same answer. You can't switch when you're subtracting. So the position that these go in have to be either first or second. Are we good so far? Okay. And the next one, we have a difference. Are these perfect squares? They're not. 2 is not a perfect square, neither is 18. Well, do I have a GCF? Yes. What could I pull out? A 2. When I pull out the 2, I have to go put it in front. It's still part of my problem. Now I'm left with x squared minus 9. Now do I have a difference of squares? Yes. So I'm going to rewrite it. So I have x squared minus 3 squared. And now I can rewrite it using that formula. So I get 2, and now I'm going to have 2 sets of parentheses. Doesn't matter where I put the plus and minus. X has to be in the first position, and 3 has to be in the second. Okie dokie, before we move on, I don't want to forget to tell you guys a few things. Two things. First, we are getting married on the 25th. And so that means that we're going to be out. And I just put these pictures because this one, yes. Because I wanted to show you guys my family. I know I've already showed you my family, but this is my family again. These are last year pictures, so they aren't new. But we are getting married at the end of this month. So we're getting married on the 25th, and we're going to be out the rest of that week and then the next Monday, which is Halloween. So we're going to be gone for 5 school days. That means I'm just trying to prepare you that the things that you will miss while I'm gone, I will record every lesson for every day. You just have to watch it and take notes and do the things. Okay. Also, another announcement, because I'm really excited this weekend. So my oldest son, Trey, and his girlfriend, Erica, they're having a baby. So I'm really excited. It's not this weekend, but we're doing the gender reveal this weekend. I am. I'm really excited.
Yes, we thought you were going to be pregnant.
Yeah.
I just couldn't say you're pregnant.
That is a negative. When I had Aubrey, I told him, please donate my parts to science. 3 is enough. I'm done. No babies for me. My son's 20. I don't want babies. I'm just, grandkids are good for me. Do what? Yes. In Georgetown, just at the courthouse. We've both been married and divorced, and it's really expensive. So we are gonna just go to do a courthouse wedding, and then we'll just go to dinner afterwards. But the next morning we fly out, and we're gonna go to the Great Smoky Mountains for our honeymoon. We will. I'll show you pictures. Well, no, yes and no. I was asked, are these all my kids? So that's my oldest son, Trey. He's 20, and my next son, Brendan, he is 18, and then my daughter is 10, and that's his girlfriend. And so he's got 2 daughters, Jade, she's 18, and her girlfriend, Madison, and then we have Scarlett, and she is 12.
So kids on the right are yours, the kids on the left.
Correct. That is correct. He never invites his girlfriend to stuff. She should have probably been in the pictures, but she wasn't there. He's not good at inviting her. So I usually have to invite her, but I just didn't. I like her, but she just wasn't in these pictures. Oh, I should also find it. My son went to homecoming last weekend. He was so adorable. I'll find a picture. Mm, Cedar Ridge. Okie dokie. One last thing. We have factor by grouping. It's not even 10, it's 9:52. So like I said, my goal is to get you guys done with notes and that maybe you can finish your homework. Again, you always want to check for a GCF. That's especially if things aren't working out right. A lot of times you didn't factor out the GCF. The next thing that we're going to do is we're going to break into two groups and we're going to factor out the GCF. I know that sounds redundant. You'll just have to see how these problems work. The goal is to get two factors in parentheses that are the same. That's our goal. And so that's why we did that one problem at the top that said negative. Sometimes you can get the things in parentheses and they're almost the same, but they don't have the same signs. So sometimes you have to factor out a negative to make them the same. And then last, we will rewrite in factored form. So factored form is factor times factor. That's factored. That's what factored form is. I will show you a simple example of factored form. So simple example of factored versus not factored. If I have 35, that is not factored. To write that factored, it would be like 5 times 7. So I'm just showing you the difference in something being factored and not factored so that you know the difference. So this is factored. It's when you have things that are multiplying to give you an answer. So that's how you can know the difference. Like this is factored, but that's not factored. So we can take 35 and we can factor it. That's what we're doing with all the problems that we're factoring. It's just making a list of things that multiply. All right, for the first one, we can scan through and see, is there a GCF? Is there something that goes into everything? Does 2 go into 1? Mm-mm. No, there's not a greatest common factor. Not a greatest common factor. Okay, well then we're going to move on. So it says that you're going to split it into two groups. And you just split it into, here is my first group, and here is my second group. So that's factor by grouping. We're splitting it into groups. And then each group is separate. Okay, each group is separate, and we're going to do the same thing we did at the top of the page. We're just looking for a GCF. So I'm looking at only this group right here. So what's the biggest thing that I can pull out of these? Well, I have a 1 and then I have a minus 12. There's no coefficient that comes out, but what about the x's? Yeah, I could factor out an x from both of them. So I'm going to factor out an x. And remember that anything you factor out has to go into the front. So it becomes x, and then I write down what I have left. So this will take me down to just 1x minus those x's, they go away, and I have 12. Hold on. Hold on 1 second because I'm feeling like I want to pause on this one and go to the next one because I think I wrote it down wrong. Yes. What? This exact same problem? Oh, man, I forgot to change them. I'm gonna change them. Number 14, sorry. Let's put a pin in it because I want to go to 14 because I feel like that I typed it in wrong. We're just gonna pause on this one because yes, we're going to 14. So same steps, we get groups. Or we should scan through and see if there's a GCF. So there's leading coefficient of 2. A lot of times you could divide out a 2 from everything. Nope, that's not the case. Can't factor out anything. So we leave it like that. We're going to look at our 2 different groups. For our first group, I have a 2 and a 10. I can definitely factor out a 2. I have an x squared and an x. I can definitely factor out an x. So out of those, I'm going to factor out a 2x and a 2x. That goes out into the front, 2x. I'm going to write down what I have left. 2's reduce, x's will reduce, so I'm left with just an x. When I look at 10 and 2, 2 goes into 10, 2 goes into 10 5 times. And the x's reduce. For the next one, you sure cannot. You know what?
I feel like it's wrong. Don't you just move the 3 somewhere?
No, we can't. No, you can start your homework, but this isn't the way that.
Why don't you sit here and think about your lesson?
Why don't I what?
Sit here and think about your lesson.
I am. I'm going to sit here and think about my lesson. 10 and 3.
Because you had to do it.
Oh, that's why. Okay. It was a 15. That's why. This is supposed to be a 15. Because I'm trying to do lessons after midnight and I shouldn't do that. Okay, that's supposed to be a 15. I did. I figured it out. Like it looks like I made a mistake on the first 2. Like that's so I'm so disappointed in myself.
Well, so then couldn't that one just be?
Okay, no, we're gonna keep working because this one is good now. So we are gonna look at the second grouping. The second grouping, I have a 3 and a 15. I can definitely pull out a 3. Well, let me tell you that my goal is to make 2 factors that look exactly the same. So my goal is to have 2 x minus 5s, but I'm not going to have a minus anything because that one is positive unless I pull out a negative 3 and a negative 3. So I put that in front, minus 3. So the first term I'm left with just an x. The second term, 15 divided by negative 3 is negative 5. So our goal, again, is to get 2 factors that are exactly the same in parentheses. So we did, right? A lot of times, like if we didn't have factor out the negative 3, we would have had x minus 5 and x plus 5. And that's an easy fix. You just go back and you change factoring out a negative. Once you get 2 of the exact same factors, then you write it out in front. One time. This is essentially factoring out the exact same factor. And then we're going to write down what's left. So what I'm left with is 2x minus 3.
Oh, now I remember.
The next one, can I factor out a GCF? Yes, what could I factor out? A 2, so I can factor out 2 from everything.
You can't factor it out.
And when I factor out the 2, it goes out into the front. And then I write down everything that I have left. So I have x squared plus 8x plus 4x plus, what's 64 divided by 2? 32. Factor by grouping. So I've got to get my 2 groups. That will be my first group. This will be my second group. When I look at the GCF of both my factors. So I have a x squared and then an 8x. I can't pull out any coefficients, but I could definitely pull out an x. So I'm going to pull out an x from both of those. I put the x out in front. Do not lose the 2. The 2 comes down. So I'm pulling out an x into the front. And when I do that, I get an x left over here plus 8 from right here. Sorry. I can pull out an 8 from both of these groups or from both of these. And so I pull it out and put it in front. I just don't want to lose my 2. It's coming down. So Angel up here, we looked for a GCF. It was 2. We divided out 2 from everything. And so I pulled it out in front. And it's got to keep going all the way down. Okay, the next set of parentheses is just everything that I had left. So this problem is like this right here. Do you know where the x came from now?
Yes, ma'am.
Oh, okay, okay. So for my second group, I have a 4x and a 32. I can pull a 4 out of both of them. And when I pull out that 4, I have to bring it out in front. Are we dividing out a positive 4 or a negative 4? A positive 4. And our goal is we need to have 2 factors that are x plus 8. So keep that in mind. So 4 divided by 4 is 1. And we just have an x left. And 32 divided by 4, that is 8. Remember, our goal was to get 2 things in parentheses that are the same. So I did it. So I still have to rewrite the 2. It's along for the ride. As soon as I get 2 sets of parentheses that are identical, I'm factoring it out. So it comes to the front. And I write down what I have left. So I'm factoring this out and putting it in front and writing down what I have left. X plus 4 goes in the second one. I'm not going to take it off. I still have to try and figure out what I did on the first one. Hey, Thank you. No, I know what I did. I know what I did. We're going to come back over here to this first question. So before I let you loose, I want you to have a lot of examples. Back to the first question because I figured out what I did wrong. I forgot a 3 out in front. Sorry, I forgot a 3 out in front. There's supposed to be a 3 there. Okay, so back to this example. I forgot a 3 out in front. We're still going to factor by grouping. We've got our 2 groups. When I look at my first group, what can I factor out? Right, I can pull out a 3x and a 3x. When I do that, and I'm going to pull it out in front, I get a 3x, and then I'll write down what I have left. So that'll reduce, and I'm left with just an x. And then 12 divided by 3, it is 4, and the x, it'll reduce. I do the same thing for my second group. What can I pull out of my second group? A 2. And remember, my goal is to get 2 factors that are x minus 4. So I divide by 2, divide by 2. And I'm dividing out a positive 2, so it's positive 2. And I'm left with an x minus 4. That's what I wanted. So, what is actually happening here when you have the same factor? I'm essentially factoring that out and writing it in front. It's the same thing that we've been doing before. So I get an x minus 4, and then I write down what's left. Now I feel much better about myself, Angel. Thank you for telling me to go sit down and think about my lesson. Oh, +2. Thank you. And we are done.